Chem Talks. Today, guys, we are going to talk about matter. And what is matter? Well, matter is what makes practically everything up in the universe. It's what makes you up, what makes your dog up, your cat, the stars, the cars, everything like that. And it's the basis for studying chemistry, which is what we're going to get into talking about today, how they relate. So first thing we need to do is talk about what chemistry is. And chemistry at its most basic is simply the study of matter, the study of the things that make up everything. We can get a little more complicated and say that chemistry is simply the study of the composition and properties of substances and the changes that those substances can undergo. So not only what things are made up of, but how those things can change over time. So let's go ahead and start talking about what matter is. We can define matter simply as anything that has both mass and volume. So if you think back, remember what mass is. Mass is simply the amount of matter in an object. It's kind of weird to define matter by saying it's mass, and mass is made up of matter. But basically, mass is just the amount of stuff that makes something up. And it's important to understand that mass is constant. If we look at mass throughout the universe, throughout all the universe, we can follows the law of conservation of mass, which says that mass cannot be created or destroyed, it only changes form. So overall, mass is constant. Volume then is the amount of space that an object takes up. How much of an area does something require? So matter is anything that has both mass and volume. Now, one thing that you may have heard of, or you might be familiar with, the idea of mass versus weight. Oftentimes, we use these two terms interchangeably, okay? But they are very different. Okay? Mass is, as we said, it's how much matter something has. It's always constant. It doesn't change, okay? Whereas weight is dependent upon your location. It's actually dependent upon gravity. Gravity pulling on the object, and the amount of gravity pulling on you will change with your location. So we can define weight simply as the measure of the force of gravity on an object. How much is that force of gravity pulling the object towards its center? And that's weight. Now, your weight will change based on where you're located. Mass will not. Mass is always constant. Weight changes. Okay? And weight, as I said, it changes with the gravity. The farther away from the center of Earth you are, the less your gravity is. The closer you are, the greater it is. So take a look at this example here. If we weighed your mass out here on Earth, well, we'd see you have a mass of about 100 kilograms. But your weight would be 980 newtons. Newtons is the unit of force. Okay? Now, if we took you up to the moon, your mass is still going to be the same. You're still going to have 100 kilograms, but your weight is now going to be much less because the gravity on the moon is much less than it is here on Earth. Okay? So mass is constant, weight is not constant. Weight is dependent on gravity. Three common states of matter that you should already be familiar with. The first one is that it's solid. Now, anything that's solid has a fixed shape and fixed volume. Okay? Neither of those things change. The next one you should be familiar with is liquid. Think about liquid in a water bottle, right? Even though its shape will change, meaning that the water will flow, its volume is going to stay the same. And then if we talk about a gas, think about a gas. You spray some air freshener, right? That gas is going to expand to fill whatever container it is, whether it's a room or whatnot. So its volume changes and its shape changes as well. One other form of gas that you may be familiar with is vapor. And a vapor is simply a substance that's currently in a gas phase, but normally at a liquid or solid at room temperature. Think about water, right? Most of the time water at room temperature is liquid. When we heat it up, it goes into a gas form. We call it water vapor, not water gas. Now, these are the three most common forms of matter: liquid, solid, gas. There are a couple other ones that we'll briefly talk about. And the most common one you're going to hear about is plasma. Okay, plasma is simply a high temperature form of matter at low pressure. We find plasma in lightning and in the sun. We find it in our fluorescent light bulbs as well. Okay? Basically, what we see happening in plasma is the electrons separate from the nucleus. Now, we're not going to get into this in any depth, but I do want you to understand there are other forms besides our three main ones. A couple other ones also occur at a very low temperature as well, what we call Bose-Einstein condensate and also quantum superfluids. We're not going to worry about these. It goes beyond the scope of this course, but I do want you to understand there are more forms of matter out there than what is common or the common solid, liquid, and gas. Okay, what we're going to talk about now is the properties of matter. Why are these important? Well, chemists use the characteristic properties of substance to tell them apart. Take, for example, these two liquid powders. Not liquids, powders. Are they the same? They look both white, both on blue backgrounds, but without understanding just by looking, we can't really tell if they're the same powder or different powders. So what we have to do is look at their characteristics, what we call their physical characteristics and their chemical characteristics. So physical properties of matter, these are characteristics that can be observed or measured without changing the identity of the substance. So for example, the melting point. Think of an ice cube. If we melt an ice cube, it's still water, right? If we heat it up even more, take it to a water vapor, it's still water. It's just a different form of it. We can look at boiling points as well, same idea. We look at the density of it, which is how much mass there is per volume, and that doesn't matter if we have 1,000 kilograms or 10 kilograms. The density is always going to be the same. We can look at the color. Okay, we can change the color of something without necessarily changing its identity. And we can look at, does it have the ability to conduct heat or electricity? Think of a copper wire, right? We can run electricity through it and observe that, but it doesn't change the identity of it. Okay, when we talk about properties of matter, we talk about what we call extensive properties. And these are properties that depend on the amount of matter that we have. Things such as the volume, the mass, the amount of energy. So it is going to be dependent on how much of it is. Now, if it doesn't depend on how much of the matter, we call these intensive properties. So these are things like your density, your boiling point, ability to conduct heat and electricity, color. Okay, all these different things are what we call intensive properties. And both extensive and intensive are what apply to the physical properties of matter. Next, we'll talk about the chemical properties. Unlike physical properties, we can't observe the chemical properties without changing it into a different substance. So we're reacting it somehow to create a new substance. And the easiest way to see it is, like I said, through a chemical reaction. Okay, example, the ability to burn. We take a piece of paper, we catch it on fire. Okay, flammability is a chemical property, but now we've made something new. Okay, so it's not the same thing. Other things, the ability to tarnish, right? Think of Mom's good silver. When she brings it out once or twice a year, first thing she has to do is to polish it to get rid of that tarnish. It's a reaction with oxygen and air. Rusting. We don't see many cars looking like this these days, or at least newer cars, so we got better technology to prevent that. But rusting is a definite chemical property. Ability to decompose, things breaking down. Okay? And ability to react with other chemical reactions is a chemical property as well. So when we have these both physical and chemical properties, we can look at how changes in either of these affect matter. So a physical change is just like the physical properties. A change that does not alter the identity of the substance. For example, change shape. If I take a piece of paper, I crumple it up in a ball, I still have paper. Or I can change the shape of the paper by tearing it in half. Now I have two smaller pieces of paper, but it's still paper. Other things include the change in phase, what we call a change of state, going from a solid to a liquid to a gas, depending on how much energy we're either adding or taking away. Changes in chemical matter. Remember, a chemical property is something that we can't observe without altering its identity. So a chemical change, we're going to see a substance gets converted into something new. Okay? It occurs when some sort of chemical reaction takes place and causes the bonds between the atoms that make up the matter to break or change form. Okay? It doesn't going to change the amount of matter, it's just going to change the form of it. Remember, when we're talking chemical reactions, the things we start with are called the reactants. Okay? This is what we start with, and we end up with something new. We end up with what we call a product. This is what's formed. This is kind of the basic chemistry. Reactants changing into products. Okay, evidence that a chemical change is occurring might include things such as a color change. Okay, an odor change. Maybe we're going to produce a smell. Think about it, something decomposes, right? If we take food, something that may have smelled good, we let it decompose over time, it's going to end up smelling. Maybe we're going to form a precipitate, as we have in this picture. We get two liquids mixing to form a precipitate or a solid. Another example is gas formation. We can combine some acid with some chalk, and we get the formation of gas bubbles here. For example, we get changes in physical properties as well. Okay, some other examples of chemical changes that you might be familiar with. Rusting. Okay, we talked about that. Fireworks are changing into chemicals, into heat, into light, into sound. Color change. When our leaves, aspen leaves, change color. I know these aren't aspen, these are oaks. In the fall, that is an example of a chemical change. Or else, as we already said, a precipitate. So these are all examples of chemical changes. So in today's podcast, we talked about matter. What's matter? Matter is anything that has mass and occupies space or has a volume. We talked about the chemical properties of matter. We talked about the physical properties. We talked about physical changes and chemical changes. All right, guys, if you have any questions on this, please stop in to see me before class, as always. Otherwise, I will see you in class next time. Take care.